So hi everyone, welcome back to my YouTube channel and let's get started with the next question of the top 150 interview questions of LeetCode. So today's question is jump game. You are given an integer array nums and you are initially positioned at array's first index and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false. So let's discuss the intuition behind the question and also the code for the same. So let's get started. So let's discuss the first test case. So we are given the question, the test cases like 2, 3, 1, 1, 4 and we have to determine whether we can reach the last or not. Okay, so let me just mark the indices of the array 0, 1, 2, 3 and 4. Okay, so fair enough. So initially we are at 0th index, right? I am at 0th position. So what is the maximum jump length that we can take according to the question? It's 0 plus 2, which is equal to 2. We can take maximum of jump length 2. And after taking a jump length of 2, at which position we will actually arrive? We will arrive at second position. Okay, fair enough. And that's the first test case. And now suppose that I am at second position. Okay, I am at first position. So what is the maximum jump length that I can take at this point? It's 1 plus 3, which is equal to 4. And it means after moving over here, we will actually 1 plus 3, we will reach at this and this, right? And we are fair enough and we have reached the last position. So let's go through the question once again and just analyze. So we are initially positioned at array's first index and each element in array represents a maximum jump length at that position, right? It means that it's not necessary that we have to take these many steps as mentioned in the question, as mentioned on the array index. Like if we are given 2, we have to take only 2 steps. The possible steps that we can take is either one step, either we can take only one step, or either we can take 2 steps. So it means at max we can move 2 positions in the array, right? So let's discuss the intuition. So as we have already discussed, like when we reach over here and when we reach, and with this possible outcome we can reach the final destination, which is the last index. So I think in this array we can simply return true. So our answer turns out to be true. Okay, so let's just look at constraints for a while. So the numbers are always in the integer range and they are always positive integers including 0. Okay, so fair enough. So let's discuss one more case where I have I think it's a second 3, 2, 1, 0, 4 3, 2, 1, 0 and 4. Okay, so let me mark the indices over here. Okay, great. So now initially I'm standing at 0th index. So how many steps can I take? At max 3. Either I can move here, either I can move at second index, or either I can move at third index. Fair enough. So let's take the one in which we can take maximum steps. It's 0 plus 3, 3. So I am standing at third index after I take the maximum steps as mentioned. Okay, so if I take step 1, I take only one step. So I'll reach at first index, and then when I reach at index 1, how many maximum steps I can take? Either I can take one step or I can take 2 steps. Okay, so what will happen? in this case. Either I can move one step, I will reach second index, or either I will go 1 plus 2, which is 3. I will move at third index. Okay, so now let's move on to this case, this scenario, the element present at index 2. So how many steps I can move further? I think it's only one step we can move. So what is the final outcome? That is 2 plus 1, 3. So at max, in all of these scenarios, we are not able to cross 0. And suppose I am standing at this index at the index where my value is 0, where I can take at max 0 steps. So 0 plus 3 is equal to 3. So overall, in a while, in this type of test case, are we able to cross the 0? The answer is no. So it means the answer over here is false. And in the first test case, I think you all have observed one thing, that there are all positive values and the values are not equal to 0. So the first indication of this question is that whenever we have all positive values in the array and there is no value which is 0, we will always reach at the final index. We will always reach a destination. So this is one of the thing which is clear after discussing this test case. So let's move further and discuss the intuition. So let me take one more test case. 1 1 2 4 0 3 and 1 1 2 4 0 3 and 2. Okay, so I think when I was discussing the dry run of the above examples, most of you have something in mind, like whenever we are not able to cross the 0, we'll always reach the we will never reach the end, and whenever we are able to cross the 0, we will reach the end. Okay, so let me take a variable. So I think this is sort of a greedy question, so we can move greedily in this case, right? So let's assume that I am at my so the maximum index where I am present at this point of time while I am starting is at 0th index. So let me take a variable max index, which is initialized to 0. Okay, so when I am standing at 0, how many steps I can move forward in this case? It's only 1. So I will update my max index to 0 plus 1, which is 1. Okay, fair enough. So now let's assume that I'm standing at my let me write down the indices of the array. So now let's take index 2, so index 1. So how many steps I can move further? I think it's only 1. So the maximum index where I can reach with the help of the value present at index 1 is 1 plus 1, which is 2. So is 2 greater than my max index? Yes. So it means I will update my max index to 2. So the maximum index till this point reached so far is 2. Okay, fair enough. So now let's go to, so now let's assume, so now we are at our index 2. So from 2 we have to reach our destination, which is 6 or something greater than 6, right? So the maximum possible index where I can reach when I'm standing at my index number 2 is 2 plus 2, which is equal to 4. So I can reach till here, right? So is my value, my current greater than max index? Yes, so I will update my max index to 4. Okay, but let's assume that I took only one step. Let's assume that I took only one step when I have reached 3, right? Because when we are at position 2, we can either reach at index 3 or at index 4, because at max we can take 2 steps at a time. So fair enough. So let's assume that I took only one step, but the maximum which I can take is 2 steps, and I can reach the max index at 4. Okay, so now let's assume that I am standing at my index 3. So what is the maximum? So what are the maximum steps that I can take? It's 3 plus 4, which is 7. So is my max index 4 greater than 7? Yes. And is 7 greater than or equal to the length of the array? That's also true. So it means we can so it means we can basically reach the end of the array. So it means we can reach the end, and our answer is true. So what has happened over here is, although when we are at index 2, we have reached 4 at some point, but when I assume to take one step, like in this case I can take at most 2 steps, right? Maximum of 2, but I assume that I take only one step and move just one value forward. So when I took this step, when I assume that when I took this path, so I was able to reach at the end. In fact I can cross the boundary, right? So it means the good path where I can reach my end is 0, 1, 2, and then I have reached 7. 2, 3, and then I have reached 7. Okay, 7, although it's a value out of our index bound, but still I am able to reach it. So it means I have crossed the array. So what is happening over here is we are greedily checking all the possibilities, right? But we are checking it in O of 10. But there is a possible scenario that we are checking all of this in O of n time. Although we can do it in O of n square time, we can store the results in some DP array. But instead of doing all of this, I thought that why not go in a greedy manner? Because greedily, as per the question, we can, in the greediest manner, we can take the maximum steps. So what I thought of, that let's calculate the maximum steps that I can take while I'm standing at any of the index, and if at that point I cross the value which is greater than the length of my array, I can simply return true, right? So that's what the point over here is, to use the greedy approach. So the time complexity of this approach turns out to be O of n, and the space complexity turns out to be O of 1. So now let's code up this solution. Okay, I've already coded. So let's discuss one more edge case that I have. Suppose I have only this one variable in my array. Will I need to do any jumps or not? Yeah, it means that the variable which is present, I can do those many jumps in that array. So it means whenever we are having the array length as 1, I can simply return true. So now let's run this code. And yeah, so when I have discussed this approach, we have seen that that till this point we can at max go till 3 steps further. We can at max have 3, but when I reach so when I suppose that I have 4 as my value, so what all maximum steps that I can take is, so the maximum steps I can take at this point is 4. But is my index 4 greater than max, yes. It means that we are never able to reach this index. I think it has gone fast, so let's dry run this code again. Okay, so when I was standing at the first index, so the maximum steps that I can take is 3. So it means that the maximum index value that I can reach here is 3. So the max index over here is 3. So let's assume that I take max of let's assume I'm at index 1. So the maximum steps that I can take over here is 3 again, because 1 plus 2 is equal to 3. Consider these values. Okay, ignore these one. Let's consider the happy path, which is actually calculating the maximum values. Okay, suppose I'm at 0th index. The maximum possible index where, so the max index where I can reach is 3. Okay, and now let's assume that I'm standing at index 1. So the maximum index where I can reach is again 3. So again the max index remains same. So when I assume to stand at index number 2, so 2 plus 1 I can max, so the max index where I can reach is 3. So over here, so when I'm at index 3, so what is the max index where I can reach is 3. It means I cannot move further. Okay, so it means that I am stuck up over here. So so it means if I'm not able to move from here only, then how can I reach the end? So that's why I have returned false. And why I have implemented this condition that my I is greater than the max index, because suppose I am at index 4. So what all max steps that I can take? It's 8. But my index value is, but the index where I'm standing is greater than my max index where I have been there so far. So that's why I'm not able to cross this index. So that's why if my index value is greater than my max index, it means I'm not able to reach that index, then I will simply return false. So that's what the question is. So if my maximum, if the value of I, which is the index where I am currently standing, is having a value greater than max index, it means I'm not able to jump at that index. So I will simply return false. And if I cross if my max index, that is the maximum index where I can reach, crosses the value of the length of the array, or maybe equal to the length of the array, I will simply return true. It means I have crossed the end of the index. Or else I will simply update my max index to max index and I plus nums of I. I plus nums of I determines the number of index, determines the max index where I can reach. And if I'm able to implement whole of this for loop, I will simply return true. So yeah, so let's submit this code. And fair enough, let's analyze the time complexity as well. It's O of n, and the space complexity, it's O of 1. So I hope guys that I am able to successfully explain this question, and if you like the way I have explained it, please do hit the like button and also the subscribe button as well. Please do share it with your friends. It would mean a lot to me, and it would help me support and motivate me to make more such videos. Thank you guys.